Hello everyone, this is Dr.R.E. I welcome you all for my video lecture in pharmaceutics. Today we are going to start with a new topic, that is extraction process. And thank you for all your feedbacks and your audit forms. And most of you have mentioned about not receiving the course objectives. So anyhow, let me explain your course objectives before I start today's topic. Well, I already told you the course objectives are nothing but your subject objectives. That is the objectives of your subject or your course pharmaceutics. That means upon completion of all the chapters or all the topics in pharmaceutics, whatever the learning outcomes, whatever the objectives you learn and remember and apply for your further requirements of your application of your knowledge procedures, that is considered as your course objectives. Well, to talk about the course objectives of your pharmaceutics, that is upon completion of the course contents, course chapters, you all will be able to gain a fundamental knowledge and you all will be able to understand the various aspects, such as you all will be able to understand the art and science of formulating different dosage forms. You all will be able to understand the most basics of applied field of pharmacy, and you all will be able to understand the formulation aspects of different dosage forms. You all will be able to understand different pharmaceutical calculations involved in the formulations. You all will be able to understand the various procedures to formulate the different types of dosage forms, and you all will be able to understand the importance of good formulation for its effectiveness. So these are all the outcomes what you are going to learn upon completion of all the chapters and the objectives, learning objectives of each and every individual chapter. Well, let me quickly move on to the topic. Today's topic is extraction process. And again, I would like to remind you about the ground rules. And today in this video session, for this presentation, I have changed few ground rules. That is, the first one, if you have any questions or doubts, as usual, you can make a list of them and revert back to me at the end of the class to get clarified. And second one, you all will be allowed to use your cell phones, your tablets, your laptops for the purpose of class. So you all should refer the research review article which is attached along with this video for further information and more detailed knowledge. And everyone must submit, this is very important, everyone must submit your field audit forms along with your other comments and suggestions, especially at the left hand side bottom corner of your audit form, and you convert that into PDF format, because whatever you mark, if it is in Word format, that is changeable, that is convertible. So for this purpose, I request you all to change it or save us in PDF format and then submit to me. And everyone must submit your field audit forms along with other comments and suggestions in PDF format, and that will be considered as your attendance for this presentation or this class. And I also request you all submit your audit forms to my personal number, because I have seen last time most of the people just simply copied what others have filled. These audit forms are nothing but you are sharing your views, you are giving your markings, you are giving your ideas, you are sharing your suggestions, right? And don't just rely on others and just simply copy the others and forward to me. That is the reason I want them to be in PDF format and to my personal number. And then your feedback is again golden, and that will be highly appreciable. I hope you understand the few changes what I have made in this ground rules for today's class. Well, now let me move on to the objectives and clear structure of this particular lecture. At the end of the chapter, that means at the end of this particular discussion, you all will be able to define the process of extraction and study the different types of extraction process. So in this different types of extraction process, you will learn what is liquid-liquid extraction by using a separating funnel, and then you will also learn about what is solid-liquid extraction by solvent extraction method, and in addition you will also learn about the process of maceration or maceration process, and then percolation process. And in percolation process you will also learn about the different types of percolation process in this particular session of the video, and this includes the part 1. And further in my next video, the remaining objectives like infusion, decoction, digestion and the counter current extraction, and including supercritical gas extraction and steam distillations will be covered. That will be covered in part 2. And today let me be clear, in part 1 you will learn the definition of process of extraction, and you will study the different types of extraction process, that is liquid-liquid extraction including separating funnel operation, and solid-liquid extraction, that includes your solvent extraction process. Well, let me now define what is extraction. So the extraction generally is defined as the process of removing soluble material from an insoluble residue, either a liquid or solid, by treatment with a liquid solvent. So you all know that in pharmaceutical formulation we use an active ingredient and excipient for the particular formulation, and the active ingredients are obtained either from the natural sources like plant or animal or mineral source, and if not, they are obtained from a synthetic or semi-synthetic origin. And this extraction process is especially involving the extraction of active ingredients from most and majoritarily from the plant products, right? That is how you can say here in the definition part, extraction generally is defined as the process of removing soluble material from an insoluble residue, either a liquid or solid, by treatment with a liquid solvent, right? So it may include the animal or plant tissues which are treated with specific solvents, and the medicinally active constituents are dissolved out, whereas the cell tissues and most of inactive or inert components will remain undissolved. So when you treat this plant material along with a solvent, only the active ingredients are dissolved out in the solvent, and the inactive material will be remained undissolved as such within the solvent. The solvent used in this process of extraction is called as menstruum, and the inert soluble material which is left over after extraction process is called as mark. And whatever the liquid along with dissolved active ingredients you obtain at the end is called as extract. So three things you have to remember here: what is menstruum and what is mark and what is extract. Now, let me explain you what are the different types of extraction. The major types of extractions are liquid-liquid extraction or solid-liquid extraction. And this liquid-liquid extraction include extraction by using a separating funnel, and solid-liquid extraction process include solvent extraction. Under this solvent extraction, we have 6 different methods. Number 1, maceration method. Number 2, percolation method. Number 3, infusion method. Number 4, decoction method. Number 5, digestion method. And number 6, counter current extraction method. And in this counter current extraction method, we have supercritical gas extraction and steam distillation. But in this video session under part 1, we will be covering only up to percolation. Well, now let me explain you what is a liquid-liquid extraction. A liquid-liquid extraction is also known as solvent extraction, and it is also called as partitioning. And it is a method to separate compounds which are based on their solution preferences for 2 different immiscible liquids, usually water and organic solvent. So I repeat, this process, liquid-liquid extraction. The liquid-liquid extraction is also known as solvent extraction, and it is also called as partitioning. And it is a method to separate compounds based on their solution preferences, that means in which solvent it is soluble, for 2 different immiscible liquids. Usually one will be water and other one will be an organic solvent. And it involves the extraction of a substance from one liquid phase into another liquid phase. And this liquid-liquid extraction is a basic technique in pharmaceutical laboratories, where it is done in separating funnels. I hope you all know what is a separating funnel. If not, I will explain you with a diagram what it is and how it is operated, as well as a common process in chemical industry and ore processing. Well, here is the diagram. So you all must have seen this in your laboratory, right? So basically, a separating funnel is sometimes it is also called a separatory funnel, or some people will call it as separation funnel, right? Whatever the name may be, it's all the same. And it is a piece of laboratory glassware which is used to partition the components of a mixture between 2 immiscible liquids of different densities. So you look into the diagram, it has got a conical shaped glass component, and at the bottom you can see there is a tap which can be opened and closed, and at the top you can see there is a stopcock, right? So you can see there are 2 different solvents filled in it. One is in blue color, other one is in yellow color, and the red colored dots represent the partitioning of the ingredients from one solvent to another solvent, right? So this is the structure of your separating funnel, and I will probably try to explain a demo with a demonstration in your laboratory when you come for your practical class. So the extraction by using this separating funnel, that means the method of extraction by using this separating funnel, or the process include typically one of the liquid will be water, as I told you already, and the other one will be an organic solvent, and this organic solvent may be either ether or a chloroform. And the funnel, which is in the shape of cone, surmounted by an hemisphere, has a stopper cock at the top and a tap at the bottom. I have shown you in the diagram already. And to use the funnel, the two liquids, one containing the mixture in solution, would be poured in through the top with a tap closed at the bottom. So initially what you have to do, if you are carrying out the process by using this separating funnel, so you have to open the stopcock, fill the separating funnel and ensure that the tap is closed at the bottom, and fill the separating funnel by both the liquids. I mean this one solvent containing the soluble mixture and other solvent containing no dissolved ingredients. So then the partition can take place from one solvent to another solvent. So then the funnel is shaken, inverted, and the tap carefully opened to release any excess pressure due to the volatility of the organic solvent. Then it is allowed to settle. Then the tap can be opened to allow the more dense liquid to be transferred to another vessel, and the remaining liquid can be transferred to wherever it is needed. So initially what you should do, you fill the separating funnel with both the solvents, and in these two solvents, one solvent is containing the dissolved ingredients and in another solvent no dissolved ingredients, and then while filling you ensure that the tap is opened at the bottom and at the top the stopcock is closed, and then you inverse in such a way the stopcock is facing downward, and you place that in your left hand palm, and you hold the funnel by means of your fingers. That means you will be holding the big bulb of the separating funnel because it is already inverted, and the tap you ensure it is facing the topward direction, in the sense it is upward, and see to that the tap is closed. Then shake the contents of flask in a circular motion, and frequently you open the tap and close. When you open the tap, the excess gas whatever has been formed within the separating funnel will be released out, right? And you repeat the process continuously for several times until the migration is completed. That means until the partition is completed. Then you separate the two liquids, and then subject the liquids for evaporation to get your partition active ingredient, which is migrated from one solvent to another solvent. So that is how you have to use your separating funnel. So the next one is solid liquid extraction. So here, as the name says, it is solid liquid extraction. In this, one will be solid, another one will be liquid. The extraction of a soluble constituent from a solid by means of a solvent is known as solid liquid extraction. Generally, it is referred to as extraction process in pharmaceutical practice. In general, if we say extraction, that is a solid liquid extraction. Vegetable oils, sugars, instant coffee, medicine from medicinal plants, etc. are made by this process are made by processing a solid material starting as a starting material by using extraction with liquid solvents. In this solid liquid extraction, we have three different methods. One is solvent extraction, second one is supercritical gas extraction, and the third one is steam distillation. Well, now let me explain about the first one, that is solvent extraction. In this case, organic solvent extraction is a process because we use a solvent which is organic. That's why they call it as organic solvent extraction, and it is a process for separating the desired substances from plant material. And the plant materials are first ground in the sense they are made into small pieces or powder, and then thoroughly mixed with a solvent such as hexane, benzene or toluene inside a tank. And the choice of solvent depends on several factors. The factors such as the characteristics of the active constituents being extracted, and the cost, and the environmental issues. Right? These are the few major factors which are to be considered during this process, and even this process depends upon these factors. Once the solvent dissolves the desired substances of the plant, then it is called as extract. I told you at the beginning itself. And then the extract is separated from the plant material. There are number of techniques for solvent extraction. In this solvent extraction, we have so many techniques. I listed out around 6 different techniques, right? In that, the first one, maceration, second one, percolation, and third one, infusion, decoction, digestion, and countercurrent extraction. Well, let us see first the first one, maceration. The maceration involves soaking and agitating the solvent and the plant materials together. So here what we are doing, so we are adding the plant material into a container or into a tank or into a flask containing a solvent, and then we are allowing it to undergo soaking. You all know what is the meaning of soaking, right? We allow it to get soaked, and then the solvent is drained off. After some period, the solvent is drained off, and the remaining extract is removed from the plant material through pressing the material or by using a centrifuge or by centrifuging. And this method does not totally extract the active ingredients from the plant materials, because this method is very simple. You are not doing any additional process. You are just allowing the plant material to get soaked in a solvent for a certain period of time, and after that you are separating it out. So in this process you cannot ensure the active ingredients are completely transferred into the solvent. So that is how this method does not totally extract the active ingredients from the plant material. Well, now let me explain the different methods of maceration. Based on the methods used, the maceration process is again divided into 2 major classes. The first one is hot maceration and the second one is cold maceration. Or you have another classification for this maceration process where you have 4 different types of maceration methods. The first one is simple maceration, second one is maceration with adjustment, and third one is double maceration, and fourth one is triple maceration. Well, let me tell you one by one. Let us go to the first type of classification, that is hot and cold macerations. So you all know what is maceration process and how it is done. You are just allowing the plant material to get soaked in a solvent for a certain period of time, and then you are removing it out. Well, in hot maceration process, the substance to be extracted and solvent are heated to certain temperature for a particular period of time by occasional shaking, and then the extract is removed. So what you are doing here, you are heating the solvent along with the plant material to a certain temperature for a particular period of time, and then your extract is removed. While in cold maceration, the substance to be extracted and solvent are kept in a cold solvent for a contact period around 24 hours to 48 hours, and then the extract is removed. So here you are not heating, you are allowing the material to be in contact with the solvent for a long period in cold solvent. For example, you are allowing it to stay for 24 hours to 48 hours. Well, and when you talk about other type of categorization or classification of maceration, simple maceration is used for organized drugs. So organized drugs is a statement which is used in pharmacognosy. The term organized means it has got some cellular structures in it, right? In pharmacognosy, the organized drugs means those crude drugs which possess cellular structures. For example, parts of a plant like roots, stems and leaves. And simple maceration is a process which is applied to roots, stems and leaves of a plant material. Well, maceration with adjustment. So here in this case, this adjustment is required. Adjustment is either you are heating it for a particular time, or you are using any additional procedure, right? And this is normally required for unorganized drugs. So organized drugs, I told you, they are having cellular structures, whereas unorganized drugs will not have any cellular structures. For example, you have here resins and gums, right? They are exudates. They are obtained from plant, right? Plant exudate is gum. Well, then you have double maceration and triple maceration. So in these two cases, the process is repeated, right? Repeated for 2 times or 3 times. And these are normally for obtaining a concentrated preparation of in a form of extract, right? Concentrated form of extract. Well, now let me explain you about percolation. So in percolation process, the plant material is initially moistened with solvent and allowed to swell. So this is the first step in percolation process, because this percolation method is most widely used, right? So in this method, initially the plant material is moistened with a solvent and allowed to swell, and then the material is repeatedly rinsed with solvent until the active ingredients are removed completely, right? And this method is more effective at removing active ingredients when you compare with the previous maceration technique. So well, in maceration we have seen we are just soaking, we are not moistening, we are just soaking, and in this case percolation, we are moistening the drug and allowing the drug to become soft. drug in the sense the crude drug, the plant crude drug. Well, let me explain you the different methods of percolation. And this percolation method is divided into 3 different methods. The first one, cold percolation, and second one, hot percolation, and third one, continuous hot percolation. And this continuous hot percolation is also called as salt extraction. Well, now let me tell you what is a cold percolation. In this process, the plant material is moistened with cold solvent and allowed to swell, and then the material is repeatedly rinsed with cold solvent until all the active ingredient has been removed. In case of hot percolation, the plant material is moistened with hot solvent and allowed to swell, and then the material is repeatedly rinsed with hot solvent until all the active ingredient has been removed. So you understand the difference? Cold percolation, you use cold solvent and you allow the plant material to get moistened with cold solvent and you allow it to swell, and then the material is repeatedly rinsed with the cold solvent. In this hot case, hot percolation, you use hot solvent and remaining procedure is the same as that of cold percolation. Well, now number 3, a third type is continuous hot percolation. As the name indicates, it is the hot percolation process that occurs continuously for several hours. The best example for this continuous hot extraction is salt extraction. So what you are doing here in this case, it is hot percolation process, but it is continuous for several hours. And the best example for this is salt extraction, because you use a specially designed apparatus called salt apparatus. Excuse me. You can look into the diagram here. So this is a salt extractor or salt apparatus, and this majorly contains 3 main parts. The first one is a boiling flask. You can see at the bottom a boiling flask, and then at the middle you can see there is an extraction chamber which is fixed to the boiling flask, fixed above the boiling flask. And then the third part is the condenser, which is at the top. So the first one is boiling flask, and the second one is the extraction chamber, and the third one is condenser. Right? This extraction chamber, you can see it is the place where you are going to feed, where you are going to add, or where you are going to keep the material, that is the plant drug material from which the active constituents are to be extracted, right? Well, so this is how it has to be fixed. So initially in the boiling flask, you have to take the solvent, right? The organic solvent or any solvent which is mentioned in the procedure, depending upon the type of active ingredient what you are going to extract out, right? You have to take solvent in the boiling flask, and after taking the solvent into the boiling flask, keep the extraction chamber or fix the extraction chamber to the boiling flask. And before fixing, you have to ensure the extraction chamber is filled with the material which has to be from which the active ingredients has to be extracted, and this has to be filled by making a thimble in the sense a conical shaped pouch or bag which is made up of normally a tissue paper or a filter paper, right? and then into which the material has to be filled, and then the thimble has to be placed in the extraction chamber, and then you have to fix this extraction chamber to the boiling flask. And along with that, you observe there are two side tubes for this extraction chamber. One is at the left hand side. You can see this carries the steam. When this boiling flask is heated through a source of heat, the solvent is boiled and it vaporizes, and the vapors of the solvent passes through this left hand side tube, and it reaches at the top of the extraction chamber, and it will try to escape through the condenser. So when it moves through the condenser, this condenser is circulated with cold water. The hot vapors of the solvent will condense out, and it will be collected and it will be dropped back onto the material which is filled in a thimble in the extraction chamber, and these drops will be hot. Right? What is happening when you boil the solvent? The solvent will evaporate and it will try to travel through the left hand side tube, and it will try to escape through top. Since at the top the condenser is fixed and the condenser is circulated with cold water in a jacketing system, the hot vapors of the solvent will condense back and it will be dropped in a form of dropwise flow onto the material which is filled in a thimble and placed in the extraction chamber. And thereby the hot solvent will penetrate through the previously moistened material which is placed in the thimble, and gradually it passes from top to bottom by extracting or by dissolving as much active ingredient as possible, and it will try to reach the tube which is present in the right hand side, and this tube is called as siphon tube. Right? Whatever is present in the right hand side with a small curve upward and again downward back into the boiling flask, connecting into the boiling flask. And this solvent, pure solvent, passes from the top region to the bottom region, and while traveling from top to bottom it will try to dissolve as much as possible quantity of active ingredient, and then it will reach the siphon tube, and through the siphon tube it will be collected back into the boiling flask. Right? And this is how the process is continuous. So if you start the cycle here, initially the fumes, fresh fumes of the solvent are going out and trying to reach the condenser and condense back, and it will be dropped out on the material which is placed in a thimble at the extraction chamber. And the solvent, hot solvent, penetrates and passes through the filled material and dissolves out maximum active ingredient, and it will reach the siphon tube, and through siphon tube it will try to reach back the boiling flask. And again a fresh solvent. Every time the boiling solvent will have fresh solvent only. The active ingredient will not go in steam, or it will not go in a form of vapors. The active ingredient will remain in the boiling flask itself, right? And this process is continued for several cycles for a long time, as long as maximum extraction has been carried out, and then it is stopped heating, and then the boiling flask is collected and the contents are transferred to a rotary evaporator, and a dry extract or dry paste of the extract can be collected back. So this is how you have to use. So so this is explanation for the Soxhlet extraction process. A Soxhlet extractor is a type of laboratory glassware which is invented in 1879 by a scientist called Franz von Soxhlet, and that is the reason it has been named after the scientist as Soxhlet extractor. It was originally designed for the extraction of lipid from a solid test material, but it is widely used and it can be used whenever it is difficult to extract any compound from a solid material. Okay, let me briefly explain you about the process. So in this Soxhlet extraction process, the dry material is placed inside a thimble which is made from filter paper and is loaded in a Soxhlet extractor, and the extractor is attached to a flask containing a solvent and a condenser at the top. So the solvent is heated, causing the solvent to get evaporated, and the hot solvent vapors travels up to the condenser where it cools and drips down onto the test material, and the chamber containing the test material slowly fills with the warm solvent until when it is almost full, it is emptied by siphon action through the siphon tube and back down to the flask. This cycle is allowed to repeat many times, and during each cycle a portion of the material dissolves in the solvent. However, once the extract reaches the solvent heating flask, it stays there. It does not participate in the extraction cycle any further. And this is a key advantage of this type of Soxhlet extraction, because only clean warm solvent is used to extract the solid which is present in the thimble and in the extraction chamber, and this increases the efficiency of the extraction when compared with simply heating up the solid in a flask with a solvent like previous methods. At the end of the process, the excess solvent may be removed by using a rotary evaporator, leaving behind only the crude extract. So I hope you understand this Soxhlet extraction by using Soxhlet apparatus, right? So with this we have come to the end of part 1, right? So let me recall whatever we have discussed, right? We have discussed about the definition part of extraction process, and we have discussed about the various types of extraction, and among the types in this video we have discussed about all the types till percolation, right? We have discussed about maceration, different types of maceration, and then we have discussed about percolation, different methods of percolation. Among different methods, we have explained in detail about Soxhlet extraction. So I have listed few references for you, and I have given one reference article, which is a review article, right? So which gives you more detailed information about the various methods of extraction process as a review and their applications. So you can go through the attachment what I have forwarded you, right? And then try to understand the more concepts in detail. So the art of being happy always lies in the power of extracting happiness from the common things what we have, right? So thank you. With this I end my first part of extraction. See you soon with the next part, that is part 2 of extraction process. Thank you. Thank you very much.